The main logic is how you will iterate over this string and keep collecting the length, skip the hash separator, and collect the word. Keep repeating the process until you reach far end and at like end of the string. We have the next LeetCode question, that is longest consecutive sequence. One brute force approach of this is you can sort it. You can sort it. So what I was talking about is brute force approach. If you sort this, what you will get with you are left with is another array, that is 1, 2, 3, 4, 100, 200. Okay, after you have sorted it, you can do a linear pass and keep a counter here. Like currently the counter is 0. You are at 1. You are at 1. The counter becomes 1. Now you are at 2. Is 2 consecutive of 1? How you will check that? If uh, this is nums of I is equal to nums of I minus 1 plus 1. Nums of I minus 1 is 1 and 1 plus 1 is 2, and is this current number, that is 2 equals 2, means this is a consecutive number. So you'll increment the counter. Now you are here. Again same logic, you'll increment the counter. And you are at 4. You'll again increment the counter. Now you are at 100. So this comparison will fail. Now you are again at 200. This comparison will fail and you are left with this thing. The result is 4. Okay. Let's iterate this approach with a similar input. If you have 1, if you don't have 2 here, if you have 1, 3 and 400 and 200. Okay, let's add a subtract between. You are at 1. You have a counter of 1. Okay. Let me write here counter of 1. Now you go here. This comparison will fail. Then you will do again, you will start with 1. Now you are here, you will do with 2. Now here you will do with 1. Now you are here, you will do with 2. Sorry, 1, because there is no consecutive. So you can maintain this counter in a set or something. When you are here, you said the latest counter is 1. When you are here, you said okay, the old counter was 1, but because they both are not consecutive, I'll maintain another counter that is 1. Now here the counter is 2. Now here the counter is 1. Now here the counter is 1. And you will pick the highest value in this thing. So you can maintain a set. But why we are not going into deep discussion in this approach? Because there is a constraint. You need to see that you must write an algorithm that runs in O(n). So there is no way you can try sorting, because sorting is n log n. Okay, so let's see something else now. For this, there is a hint. If you can try pausing the video and try with the hint is this. Use a set, and the key idea is to only start counting from numbers that are beginning of a sequence. Okay. And how you'll check that? If a set doesn't has the previous number, means it is a beginning of a sequence. So let's come here. So you have this array, and if you convert it, if you make a set out of this thing, again this is our array. This is again our set. Both are identical because there are no duplicate elements. But when you apply this logic, you are left with 100, 200 and 1. Because let's see, let's apply this formula for 3. 3 is here, 3 minus 1 is 2. Set has 2. Yes. Then this not set has become false. Again try to place 2 here. 2 minus 1 is 2. And set has 2. Yes. And set doesn't has 2. False, because set has 2. So by applying this logic, you are left with 100, 200 and 1. And because now you have starting sequence, all possible starting sequences, what you can do is you can try to find the continuous sequence for each beginning of sequence. So I'll have to write here beginning of sequence. So this is beginning of sequence. So this is array and this is a set. Okay. So suppose you are at beginning of sequence of 100. Okay. How can you get continuous sequence of 100? The next one, if you find 101, then it's a continuous sequence. You don't have one. So 100 is a failing here. Not 200. Means 100 is not failing, but 100 is it only is single number with a sequence now, as of now. So we'll like maintain a counter. Currently our counter is 1 because of 100. Okay. Next 200. We don't find 201. So the counter for 200 is 1 only. Will not change it because our counter is not changing. We'll only change it if we found a bigger counter, a bigger sequence, a consecutive sequence. Okay. Now we are at 1. We are at 1. Okay, counter is 1, no problem, we'll not change it. Now we'll search for 2. Does this set has 2? Yes. Let's increment the counter then. Counter is 2 because we have 1, 2. Does this set has 3? Yes, this set has 3. Counter is 3 now because we can find the next number, that is 3. After 3, we'll again ask the same question. Does this set has 4? Yes, this set has 4. So the counter becomes 4 now. Now again same question. Does this set has 5? No, this set doesn't have 5. So we can't increment. The counter stays at 4. So this is our solution. This is our solution. Let's see how we'll do it in the code. And so also about complexity, we are using a set here. So that is that max size of the set can be same as of the array. So that is O of n, and for each array here, for each item we are finding its sequence. So for each item means that is a linear loop. So that is the thing. Either you can try to loop on the set or the array, and because the determining sequence won't change if you have duplicates or not. So suppose this array doesn't have any duplicates, but if it has a duplicate of 1, let's say, so if you find sequence of longest sequence for this one or the other duplicate one, the result won't change. The counter still stays 4 because of 1, 2 and 3 and 4. So we'll rather operate on the set, because that will give us some improvement in performance. I'll show you that how while we'll submit the solution. So we're looping over the set, and for each item we are checking if is the beginning of the sequence, and if it's the beginning of the sequence, let's start local streak at 1. Streak means longest consecutive number, means counter. And I haven't talked about this, but this thing, we are creating an empty set, not empty set, but we are creating a set out of the nums array, and let's start with the global streak of 0. Means global string means the counter, that we are keeping track of. That is our final answer. And if it's the beginning of the sequence, then start with 1 then, because suppose we are at 1, and 1 is the beginning of the sequence, then the current counter will start at 1. Okay, and this is the number. 1 is our number, and we'll keep increasing our counter till we found the next consecutive number. That is, the set has current plus 1, the set has 2, the set has 3, the set has 4. But this will fail when we'll try to find 5 in the set, because that doesn't exist. Then we'll get out of this loop. Till then we'll keep incrementing this counter. Okay, and keep incrementing the number as well. So that will help us to progress forward for this search in the set. And finally, we are updating the global streak, that is the counter, and it is just a simple way of saying give me the max of either current streak or global streak. I just didn't use the math.max library utility, because this was a very simple thing. So, and after we have done this for every number in the array, just we are returning the global counter, or the biggest like frequency. So we have already talked about the complexity. We are not sorting because of the uh, constraint of O of n, and the complexity is O of n for time and O of n for space. Let's try to run this code. Longest consecutive sequence in LeetCode. Longest consecutive sequence. So I've already tried this, and this solution also has some kind of useful comments, like suppose we have these nums array. So beginning sequences will be 100, 200 and 100 and 200. And why we have used set instead of the nums array itself, because try iterating over the unique values. I've already discussed why iterating over nums or set doesn't change our answer. Just to prove our point why set is necessary, let's do with nums first. So cases are running, 3 cases, and here it will hit a time limit, I guess. Yeah. So in order to recover of this TLE error, we'll use iterating over set instead.